Ever wonder how your favorite app, just works? Even with millions of people using it all at once? Well, it's not magic. It's all about something called system architecture. And believe it or not, we're going to break it all down using a pizza shop.
Yep, you heard that right. We're going to follow a tiny pizza shop on its journey to becoming a global empire. And what you'll see is that the challenges it faces, they're pretty much the exact same problems that engineers tackle every single day to keep our digital world running.
All right, so let's start at the beginning. Part 1, the solo chef. Every great idea, every app starts small. Picture this, a cozy little pizza shop with just one absolutely brilliant chef. This person does it all, right? They take the orders, they knead the dough, they toss on the toppings, they manage the oven, everything. It's super simple, it's all in one place, and for the first handful of customers, it works like a charm. Now, in the tech world, we have a name for this. It's called a monolithic architecture. Think mono, like one big stone. Everything, the user interface, all the business logic, the database stuff, it's all packed into one single code base. And you know what? A lot of folks, like the sources from Index9 and AlgoWorks point out, say this is the best way to start. It's fast, it's straightforward, and it gets your idea out the door quicker than anything else. But what happens when you get really popular? All of a sudden, the secret's out. There's a line wrapped around the block. Our amazing solo chef is now totally swamped. Orders are getting mixed up, pizzas are taking forever. The very success that they dreamed of is now threatening to crash the whole operation. This is that first big scaling crisis. Okay, so part 2, handling the rush. The solution seems obvious, right? Just hire more chefs. But that just creates a brand new problem, total chaos. You can't just have customers yelling their orders at random chefs. So you bring in a host, someone who stands at the front door, and their only job is to guide the next customer to the next available chef. It brings order to the madness and keeps the flow smooth. And that host, my friends, is our load balancer. It's basically the traffic cop of the internet. Like the folks at Cloudflare explain, a load balancer's job is to take all that incoming traffic and spread it out evenly across your servers. This is so critical. It doesn't just make things faster. It's what keeps the whole service from going down when you get popular. So how does this host actually decide which chef gets the next customer? Well, they use a few simple strategies, or algorithms. One is called round robin. Super simple. The host just points to each chef one by one in a circle, chef 1, then chef 2, then chef 3, and back to 1. A slightly smarter way is least connections. The host glances over, sees which chef has the shortest line, and sends the new customer right there. Makes sense, right? Okay, but what happens if a chef's oven breaks? Or they, run out of cheese? The host needs to know about that fast. This is where health checks come in. The host is constantly, quietly checking in on each station. You good? You good? You good? If one chef doesn't respond or says they're having trouble, the host immediately stops sending people their way. That's called failover. The traffic gets rerouted to the healthy chefs, and the customers never even notice there was a problem. One little hiccup doesn't bring down the whole restaurant. All right, part 3, the pepperoni problem. So our shop is humming along now, handling the crowds like a pro. But a new problem pops up, a bottleneck. Turns out the pepperoni pizza is an absolute smash hit. Like every other order is for pepperoni. And making each one from scratch, grabbing the dough, ladling the sauce, placing every single pepperoni, it's the same repetitive job over and over, and it's slowing the whole kitchen down. The solution to this kind of repetitive work is caching. And the very first, fastest layer of caching is like a regular customer who knows exactly what they want. They don't even look at the menu. They walk in and say, "I'll have the usual." That's your browser cache. It saves stuff like images, logos, and bits of code right on your own computer. So when you visit that site again, it loads instantly without having to ask the server for everything all over again. Okay, the next layer out is something called a content delivery network, or CDN. This is awesome. Imagine your delivery drivers keeping a few hot, ready-to-go pepperoni pizzas in warming bags in their cars, parked in different neighborhoods. When an order comes in from that area, bam, they can deliver it instantly without driving all the way back to the shop. CDNs are just like that. A network of servers all over the world that store copies of your website's content so it gets delivered to users from a location that's physically close to them. Super fast. And then, for the really popular stuff, right inside the kitchen, we have the distributed cache. This is like a giant shared warming station. Any chef who needs a pepperoni pizza doesn't have to make it. They just turn around, grab a perfect hot one from the warming station, and it's ready.
In the tech world, tools like Redis are this warming station. They keep frequently needed data, like your user profile, in memory for ridiculously fast access. We're talking sub-millisecond. It's unbelievably quick. So you see, caching isn't just one thing, it's a whole strategy with multiple layers. When your app needs a piece of information, it doesn't just go straight to the busiest person. First, it asks the customer, that's the browser cache. Then it checks with the local delivery driver, that's the CDN. Then it looks in the kitchen's warming station, the distributed cache. And only if it can't find it anywhere else does it finally go and bother the main chef, our primary database.
So, our pizza empire is massive now, but we've slammed into another wall. Part 4, the chaotic kitchen. That one big kitchen, that monolith we started with, it's now a gigantic, sprawling, chaotic mess. You've got dozens of chefs all trying to do everything, and they're constantly tripping over each other. And worse, it's super fragile. If one person messes up the dough recipe in one corner, it can ruin the dough for the entire operation, grinding everything to a halt. The answer? It's time to specialize. We're going to break up that one chaotic kitchen into a series of smaller, independent stations. You have a dedicated dough station, a sauce station, a topping station, and an oven station. Each team is an expert at just one thing, and they can all work in parallel without getting in each other's way.
And this is the perfect analogy for moving from a monolith to a microservices architecture. Think about it. With the monolith, the one big kitchen, if you want to change the sauce recipe, you have to shut down and restart the whole kitchen. If you need more oven capacity, you have to build an entirely new giant kitchen. But with microservices, or specialized stations, everything is independent. Need to upgrade the ovens? Just upgrade the oven station. Need more sauce? Just scale up the sauce team. And as some sources point out, if a small fire starts at the sauce station, it's contained. The dough and topping stations can keep on working. But, and this is a really important piece of advice, don't just jump straight to microservices because they sound cool. The full-stack developer roadmap puts it perfectly. Start with a monolith. Extract services only when you have clear reasons. For most new projects, a monolith is way easier and faster. You only break it apart when you're actually facing the scaling problems that justify all that extra complexity.
Okay, we are almost there. But this new system has created one last tricky problem. Let's call it the forgotten special order. Imagine a customer places a really complex order with Chef A, no onions, extra cheese, gluten-free crust. But then our super efficient host sends that customer over to Chef B to pick up their pizza. Chef B looks at them blankly. They have no idea what that special order was. The state of that customer's request, it's been lost. The modern way to solve this is by designing what we call stateless services. So instead of a chef having to remember the order, the special instructions are written down on a ticket, a physical ticket. Now it doesn't matter which chef the customer talks to, A, B, or C. Any one of them can just read the ticket and make the order perfectly. Every single request from the customer contains all the information needed to fulfill it. This makes the whole system so much more flexible. And by the way, this is exactly why you sometimes get randomly logged out of a website. Your next click got sent to a different server, a different chef, who had no idea who you were. Now, some older systems try to fix this with something called sticky sessions. They basically use your IP address to make sure you always go back to the same chef who remembers you. But as you can imagine, that has its own problems. So there you have it. Let's recap the whole journey. We started with a simple monolith, our one amazing chef. Then we added load balancers to handle the crowds, more chefs and a host. We used caching to speed things up by pre-making popular items. We evolved into microservices, our specialized stations, to scale different parts independently. And finally, we made our services stateless by using order tickets that any chef can read, from a tiny shop to a global empire. Each one of these ideas, load balancing, caching, microservices, it's a tool to solve a very specific problem that comes with growth. The real art of system architecture isn't just knowing what the tools are, it's about correctly identifying which problem you actually need to solve right now. So that leaves one question for you to think about. As your application grows, which scaling problem are you trying to solve next?